this video we're going to be looking at metallic bonding. The learning intention for this video is for us to develop an understanding of what metallic bonding is, to explore the atomic arrangement of metallic substances, to explore their physical properties and be able to explain them in terms of the structure as well as the type of bonding present. And lastly, we're going to explain why metals are excellent conductors of both heat and electricity. Over on the next page, I have the list of the success criteria that you should be able to address by the end of today's video. The first thing I want to get you guys to do first is answer these two questions for me, okay? I just want to see how much you guys recall. So firstly, answer what is a chemical bond. Some of you guys may know this already, some of you guys don't know, so it's fine if you skip the first question, but you should be able to answer the second one hopefully. So the second question says, why do chemical bonds form? Give yourself a minute and then we'll compare our answers together. So let's just quickly talk about what is a chemical bond. So a chemical bond is, you can think of it as an imaginary force that kind of holds or binds all the atoms in a compound together, okay? So a compound is made up of many types of atoms, and these are the chemical bonds that hold all these atoms together in a compound, okay? So there are three types of chemical bonds that we're going to be looking at, but for today's lesson we're only going to be looking at the first one, which is about metallic bonding. But the other two types of bonding that we are going to go through include covalent bonding and ionic bonding. And as you can see by the image on the right hand side of here, this shows you the fundamental differences between each of the different types. So as you can see over here, metallic bonding, as given by its name, is a type of chemical bond that exists between only metal atoms. Covalent bonding, on the other hand, is a type of bonding that only occurs between non-metal elements, and ionic bonding is a type of bonding that occurs between a metal and a non-metal, okay, but not always necessarily though. So the reason why why do atoms form chemical bonds is because that they are initially unstable, okay? And because they once become stable, they will therefore. Now that we know what a chemical bond is, let's explain why do chemicals actually form chemical bonds, okay? And the reason why they form chemical bonds is so that they become electronically stable. Now, you guys already remember that monoatomic atoms, okay, so singular atoms, they are generally unstable because they don't have a complete outer shell. So what they do is that in order to actually form a chemical bond to become stable, they will either donate, accept, or share electrons with the neighboring atoms, and that's how they actually bind it together, okay? Now you guys should know this, that noble gases are actually inert, so they won't actually form any chemical bonds with any neighboring atoms at all, as they already have a complete outer shell. So noble gases are found on this particular group over here, so you can refer them as group 8 or group 18. An example would be neon and argon, as you can see here, where it has a complete valence shell. Now, before I actually show you what metallic bonding is, you need to understand what does the atomic structure of a metal substance actually looks like. So if you guys actually zoom in, this is what the metallic structure actually looks like over here. So obviously metal is a 3D structure, and what it does is it consists of metal cations. So cations are positively charged ions, okay? And they are surrounded by a sea of delocalized electrons, okay? It's referred to as a C because there's an abundant amount of electrons, okay? And the type of electrons is referred to as delocalized electrons. What delocalized electrons are? They are essentially the valence electrons that were lost, okay? So in order for you to become an ion, you have to lose the electrons, and so these are the valence electrons over here. But these valence electrons are not associated with a single atom at all. So what that means is that this electron over here can actually freely move around the actual structure, okay? Now, as you can see over here, all metal substances are kind of arranged in this similar manner where it's nicely ordered, okay? And this particular 3D structure of a metal may be referred to as a lattice crystal shaped structure as well. So this is another way of describing the structure of a metal substance, just something that you might want to note down. We describe metallic bonding as the attraction of the metal ions, meaning the metal cations, to the surrounding delocalized electrons. And it's this type of attraction that kind of holds all of the metals in place. So as I initially stated before in the previous slide, okay, notice that the structure of the metal substance has a nice order structure for the metals. And so as you can see, they're evenly spaced out, and in between the gaps of the actual metal cations, you can see that they have these delocalized electrons, and these delocalized electrons are mobile, meaning that they can freely move through the gaps of the lattice structure. The reason why we have delocalized electrons was because that electrons become stable by losing these electrons. And essentially the word delocalized means it's free. And if all the metals do this, then you will therefore have a sea of delocalized electrons that can surround the lattice. And my last point over here just says that it is the nature of this delocalized, the sea of delocalized electrons that kind of holds all the metal atoms together. So have a go at answering this question over here, and we'll compare our answers together. So for this particular question, which reads, what does it mean when valence electrons are said to be delocalized? It means that the electrons can freely move between atoms, okay? So it's not electrons being able to freely move within the same atom, meaning that between different electron shells, it's actually between neighboring atoms. So that's why C is the correct answer. See whether you can answer this question. This is a true or false question. So this question reads, the forces of attraction between metal cations and the sea of delocalized electrons are enough to overcome the repulsion forces between cations. In this case, the correct answer is going to be true. Now, the reason why it's going to be true is because that if you think about it, if the forces between like the metals were weaker than the forces of repulsion, then these atoms over here, metal atoms, the neighboring metal atoms, wouldn't actually be next to each other. They would actually split off, and therefore this would imply that metal atoms are actually brittle instead. So that's not the case, hence the answer is true. Let's now explore the physical properties of metals. Now, you guys should already be aware some of the properties of metals already, which includes the capacity to be able to conduct both electricity and heat. They generally have a higher melting point. They are lustrous, meaning that they are shiny. Malleable, which means they can be reshaped. And ductile just means that they can be made into wires, okay? And each of these properties over here can be explained by the structure or the type of bonding that's present in metallic substances. But hopefully by the end of this video, you should be able to do these two over here as well as this one. So let's look at why metals are able to conduct electricity. But before we do that, we need to actually know what are the conditions for any substance to conduct electricity. For any substance to be able to conduct electricity, you need to have charged particles, okay? And not only that, these charged particles must be mobile and free moving. What that essentially means is that these charged particles are able to therefore carry the electric current throughout the actual substance itself. The reason why metals are able to conduct electricity is because that they have these delocalized electrons, okay? These delocalized electrons are mobile and free moving, okay? So that was a second condition. But the delocalized electrons, because they are an electron, they have a negative charge associated with them. So this is a charged particle that can move, and hence it can therefore carry the electric current throughout the actual structure. This is also portrayed by this video over here as well. So notice that when the battery is off, the delocalized electrons in the actual, I suppose, metal, they freely move in the substance. But when it's connected into a circuit and the actual power is on, which will soon happen, notice that the electrons move from the negative section from the battery towards the positive. And that makes sense because electrons are negative, they're attracted to positive charges. So very soon you should be able to see this. And as you can see here, because that the power is on, you can also notice that the light globe is also shining as well. We're now going to be looking at why metals are able to conduct heat. The reason why that is because that when you actually heat the metallic substance, you're actually increasing the kinetic energy, meaning you're increasing the motion of the delocalized electrons found in the metallic substance. So this is a metallic substance over here. You've got the delocalized electrons that kind of go around the gaps, you could say, of the actual structure. And so that these electrons are pretty much getting excited. They're getting very energetic. And because kinetic energy is proportional to temperature. By increasing temperature, you're increasing the energy, and what that essentially means is that this energy can therefore be transferred throughout the metallic substance, which is why it is able to conduct heat very well. This is also shown by this particular video as well.
Similarly, this free flow of electrons explains the ability of metals to conduct heat and electricity. When you heat up a metal, the free electrons quickly start vibrating. Increased kinetic energy means increased temperature.
All right, what we're going to be looking at now is why metals have a high melting point. So the reason why they generally have a high melting point is because the metallic bonding is very strong due to the strong electrostatic forces of attraction between the metal ions, which is a positive charge, and the localized electrons, which has a negative charge, okay? And as you can see by this particular diagram over here, as you kind of move left to right, we can kind of see that initially the melting point actually increases, but then it eventually drops off, okay? So there isn't really any clear trend, but generally speaking, as you start from the first column or the first group, melting point increases as you move left to right, since the number of valence electrons generally increases as well. The next property we're going to be looking at is malleability. And as I stated earlier on, malleable refers to a substance's ability to kind of be deformed and reshaped into any shape possible, okay? So if something is characterized as malleable, it's not brittle because it can be reshaped, it's therefore not breakable at all, okay? So as you can see by this video, this
If
also
you hit a metal
explains
with a
why it's
hammer,
malleable.
it doesn't break, it just dents. Metals are able to deform in response to an applied force. The mobile sea of electrons shields the cations from each other, preventing violent repulsion and allowing the metal to change shape.
So in this particular video over here, it's essentially saying that metals are actually malleable and they don't actually break off at all because the delocalized electrons pretty much shield the substance, therefore preventing electrostatic repulsion. So that's why I've said hammering a metal will cause dents rather than actually breaking it. And the reason why that is because your delocalized electrons prevent electrostatic repulsion between the metal cations. Next property we're going to be looking at is ductility or ductile, okay? So when a substance is considered to be ductile, it has the capacity to be made or drawn, that's the key word here, drawn into wires. And the reason why it doesn't break off and it can be made into wires is, again, the sea of delocalized electrons surrounds the structure and shields the metal ions from repelling from one another. And this is shown in this particular video clip as well.
In contrast, a metal can be pulled into a long cylindrical shape because the cations can line up, shielded from each other, as the fluid-like sea of electrons flows around them.
And the very last property that we're going to be looking at is lustrous. Okay, so metals are lustrous, meaning that they are shiny, and the reason why they're shiny is because that there are delocalized electrons that's found on the surface of the metal, and these electrons are able to absorb the radiation from the sun and therefore emit that back to our eyes, and that's the reason why metals are shiny. Now that we've gone through all the content, I would now like you to answer the following questions. So for this particular question over here, it reads, what are the electrons called that are involved in the metallic bond? So we know that for a metallic bond, this is the force of attraction between the delocalized electrons and the metal cations, okay? So because we know delocalized electrons are made of valence electrons, that could be correct. This is still technically correct as well. We know that the delocalized electrons form a sea that kind of surrounds or coats the structure. So therefore, the correct answer is going to be D. D is probably the best answer for this option. For this question over here, it reads, how are positive ions in a metal sample arranged? We know that the 3D structure of a metal is nicely ordered around. So therefore, it's going to be C. They remain in an ordered arrangement. For this question over here, I can hit a metal with a hammer without the metal shattering because of its, because this is talking about hammering a metal. into thin sheets without breaking, this is referred to malleability. The next question is, in general, what can be said about the melting points of metals? The correct answer should be C, they are high. What does malleable mean? Malleable means it's be able to be reshaped, so A is going to be the correct answer. Metallic bonding is an attraction between the positive ions and electrons, so therefore D is going to be the correct answer. Why do metals conduct electricity? The correct answer for this over here is going to be C. So the electrons are delocalized, and these delocalized electrons are mobile and therefore can carry an electric current. Now that you answered this, I would now like you to answer this question over here on the class kick Word document, and also answer these questions over here as well. This is the end of today's video. Thank you for watching. I'll see you guys in the next video. Peace out. Bye.